thank you for being here today. I'm Guillaume Michalag. I'm head of security and integration, generally working on broader compliance topic like sustainability also at Exoscale. So in case you don't know Exoscale, so we're a public cloud provider based in Switzerland. Our headquarters in Lausanne, but we have a broad European footprint with over 8 zones in Europe, including 2 in Germany. So I'm here today with Dr. Simon Shillaker.
Yeah, hi. I'm a senior software engineer, and I've been working on the problem of cloud sustainability for 4 years or so, 2 different cloud providers.
And I will add one more thing about Exoscale. We are part of A1 Telecom Austria Group, so we are a subsidiary of A1 Digital in Austria. So the topic I'm going to talk about today is a topic that really should concern everybody, because we're going to talk about the sustainability of the cloud. And well, we are all cloud users, one way or another, directly or indirectly. And there's more and more claims being made by cloud providers and about their sustainability practice, how green they are. And the problem is that you get numbers, but today they can be very often rough guesses. It was sometimes misleading even. And it's actually a pretty complicated problem, which so we want to explain you why this is the case, but was also there is some hope in this industry because we are starting to get the tool and the methodology. We need to fix that. So the content will be split into 4 different parts. First, we address why we should care about all this, why this matters, why those claims that we can get from left and right are most likely wrong, and why it's hard to actually get them right. And then we'll finish with showing that there are solutions that are appearing, and we'll talk about what we can do about that situation. So let's start with the first part. Why should we care? So the tech in general, and there's been a lot of talk about tech being there to make the world a better place, supposed to make us more efficient, to more connected. Like if we look over the last few years, there's also like a dark side to the tech. I mean, privacy issues, addictive patterns, environmental impact. So we can sometimes wonder if we cannot sometimes be part of the problem. So 3 reasons to care about the environmental cost of the cloud. So first reason is that, well, actually it's not insignificant. And it's getting worse. So that's a big number, 941 terawatt hours. That's the projection for what data center will use globally in 2030. That's the IEA that has published a study. And to give you an idea of what this means, it's like about what Japan is using today. So, and still Japan has some issue with still a very large economy, and that's data center uses much data, or will use as much data in 2030. So it's big, but I mean there are other industries which are very big polluter: construction, the transport industry, airlines. The difference is that we are on an explosive growth trajectory. Like this number, actually, if in 2000, this is 3 times more than in 2024. So basically, we are like currently with the AI boom, we are doubling every year, every 2 years. So that's like, yeah, there's a potential for growth that's unknown but very large. So that's why it's a big concern. Second reason, so like there's a lot of claim flying around, and it's really difficult to trust any of the things that you're being told by the different actors. You will hear things like, well, we are green, or we're committed to sustainability, or we're carbon neutral. Fortunately, I think like the people that used to make this silly film stopped. It was getting really nonsense given the obvious boom in the energy consumption, and all the data centers are being built. The issue is, like, nobody was really lying either. I mean, there was ways to get to the numbers you were given, but the problem is that there was plenty of different methods, and you didn't know what methods they used to make those claims, what was the scope they calculated them on, what was the assumptions they made. So in the end, you had claims, but you had no way to compare them or to trust them. So there was absolutely no real transparency, just noise. Now, 3 reasons why you need those numbers and why you need them to be accurate. First is the regulation. So probably all of them aware of the CSRD. So CSRD is this big European regulation that mandates larger company to communicate on their environmental impact. So you have to publish a report every year. If you are a company of over 1,000 employees, you have to publish a CSRD report every year, which must absolutely include your scope 3. Your scope 3 is all the indirect emissions that you're going to cause by the services, for example, and the services you're buying. So if you're our cloud user, you're supposed to also include those figures in your CSRD report. So you will need that. But even if you're not directly concerned by CSRD, another big force that will make those figures necessary is procurement. Some RFP, some will mandate that you can provide those figures. So even if you were not necessarily, if you didn't have to do like this exercise of calculating your impact because of the regulation, it will come from your customers that will force you to. Finally, like reputation, it's so difficult to gain, so easy to lose. Actually, here the risk of being accused of greenwashing if you make inaccurate claims is high. Even it's probably worse than not doing anything at all. So it's important to have number, but you also need to be able to explain how you got this number, to be able to prove they have the means something. Otherwise, you don't have numbers, you have just marketing. So now I'm going to hand over to Simon, which is going to explain you why your numbers are wrong. And you will see that the answer lies into the fact that the cloud is very complex and this complexity is hidden from here.
Yes. Okay. So the word cloud is kind of a misnomer. What we can instead think of is a big iceberg. Because really the cloud is this immense global effort to build the largest distributed computing thing we've ever seen in history. And so above the water is what users see, which is pretty much infinite resources that can be launched anywhere in the world at the click of a button. For example, AWS has 128 zones in 40 different countries. Now, it's difficult to underestimate how complex this thing is underneath the water. So if we start from the ground, there's the buildings, and in them are power supplies, generators, cooling, batteries, all of which is going to outlive the devices inside them, possibly people in this room. And then the devices themselves, of which there are hundreds of thousands, millions, each of which contain GPUs, CPUs, RAM, SSD. And then there's all the stuff that connects those servers. There's the cables and the switches and the routers. And so if we try and imagine the environmental impact of this vast global web of all this stuff, we'd have to think about the construction of the buildings and the devices, the energy and water they consume, and also what it takes to get rid of them. So, sorry. I can tell you there's a lot of things there.
Yeah.
TLDR, there's a bunch of stuff, and it's really hard to work out all the objectives. So an interesting way to think about cloud is much more like real estate than a tech business. So essentially, we make a huge CapEx expenditure on these fixed assets, buildings, devices, and things. And much like real estate, we have to then sweat these assets by renting them out. And the secret sauce in the cloud is basically taking what is essentially the same assets and using them more efficiently with cheaper utilities. And that is really, really the key. That's what makes a cloud business good or bad. Now, unfortunately for us, this means people aren't super transparent about how they run their businesses. But that's exactly what we need to know. To estimate how bad the impact is, we need to know what happens internally. So there's this kind of structural problem where no one's going to share the data that we need. The other complex thing about the cloud is that it's really a web of different actors. So first of all, we start with users. Users are the people who say what they want, where, and at what scale. Then the cloud providers are the ones who buy the hardware. They put it in buildings, and they decide how to get rid of it. Often, the person who runs the building, the data center operator, is different to the cloud provider. They buy all the batteries and the generators and whatnot. And then there's the utility operators who determine the energy mix going into the buildings. And then you got the people who make the hardware and get the raw materials out of the ground. Again, another actor in the system. The important part here is not only are people not interested in transparency, but also there's just a bunch of people involved. Nobody's in charge, and nobody has all the data that we need. So I think we've done a listed how difficult it is and how hard it is to get the data. And so now we can start thinking about how we might try to solve it. So we can start thinking of the three pillars of cloud impacts. The first one's electricity, obviously what the machines take in and how that's generated. Then there's water, similar to electricity, is how much is consumed. But with water, it's very important what happens to the water after it's been used. And then we have embodied impact. And embodied impact is the impact that happens outside of the usage of the thing. That means building it and getting rid of it. So each one of these three pillars has its own complexity. So we'll start with electricity. So electricity is interesting because what you pay for and what you get are two different things. With electricity, when you pay, you're paying someone to generate some electricity and inject it into the grid. But no matter who you're paying, you're still consuming from the same plug, from the same grid. And this is important in cloud computing because a lot of cloud providers will have power purchase agreements, or PPAs, where they say to a provider, for every kilowatt hour I consume, you're going to generate 1 kilowatt hour of green energy. But at the end of the day, I'm still consuming from the same grid. So PPAs are good. They result in a lot of investment in the green energy sector. But these data centers are still consuming the energy mix of the country that they're in. The problem is that energy mix varies hour to hour. And so on the right here, this is a screenshot of something called electricity maps. I can recommend it. It's very interesting. And here we've got Germany. So Germany is an interesting case because the carbon intensity of the German grid can vary by an order of magnitude throughout the day, depending on demand, climate, etc. In order to accurately assess the impact of data centers' consumption of electricity, we need this kind of data. We don't need an annual average. We need a granular data. Then we can think about water. This big number on the left here is the number that Google reported in 2023. 23 billion liters of water they consumed for their data centers globally. As Guillaume said, much like power, this is doubling, trebling all the time. So a lot of water, essentially. And the bit that we often forget as well is that there's a hell of a lot of water consumed in manufacturing devices. So in the semiconductor industry, you have bits of silicon that need to be rinsed after each step. The water that you rinse them in has to be ultra purified so that there's absolutely nothing in there that will get in between these wafers. The process to purify the water is energy intensive, and the consumption of the water is even higher than the consumption of the data centers themselves. So think about a number here, 64 million liters per day. It's unimaginable amounts of water. It's just a hell of a lot. The important thing about data centers is that each data center will use water differently. Some of them use evaporative cooling, evaporating water, that's not to take away heat. This results in a loss of water loss to the atmosphere, which is bad. Other data centers, like with Exoscale, have a closed loop system where you have water going around in a loop. You take the waste heat out of that water and you reuse it. So this is a key thing about a lot of the water numbers that you get. Water consumption and water loss are very different. And unfortunately, the numbers we have are not particularly clear. So it's a big problem with not very good numbers. And finally, embodied impacts. So like I said, this is everything that happens before and after the device is used. So we can think about the supply chain. We've got the raw materials, obviously, the big cranes and stuff in the background. This process consumes a lot of electricity and water and has a lot of environmental impact outside of that for the local area. The manufacturing itself, as I said, consumes a lot of water. The transport, and like I said, it's this vast global industry. There's a lot of fossil fuels burned in just transporting stuff around. Operation is when it's being used. And then end of life. Recycling electronic devices is very difficult. Extracting metals from said devices is incredibly energy intensive. And this part of the impact is really, really significant. It's easy to say, oh yeah, holding it and getting rid of it. It's not going to be as bad as using it, but in fact, it can be worse. And to demonstrate that, we're going to talk about the use of a device in two different places. So this is just a laptop. If we imagine the laptop has been running for 4 years, 6 hours a day, consuming 60 watts. The base impact we start with, the embodied impact, is the same if we're in France or Germany. However, the energy mix in France is about 4 times less carbon intensive than Germany on average. And so you can see over its life, we've got the gray part is the embodied impact, and the red part is the impact from using the thing. So in France, actually, the embodied impacts are much more significant than the usage impacts. And this is interesting. As grids get progressively greener, we have to worry less about the usage and more about the embodied impact. An interesting thing in France, if you buy a smartphone in France, even if you charged it 24/7 for 5 or 6 years, the impact of that electricity would not outweigh the impacts of building the smartphone in the first place. Just a side note about these estimates, these are from a thing called Boa Vista. It's a French association which does some great work on open source tools for calculating this stuff. There we go. Embodied emissions are significant. So now back to Guillaume, who's going to tell you why it's difficult to fix these numbers.
Thank you. And I'll go through 4 different reasons. The reason why is that there's no standard cloud provider. So as we explained earlier, like cloud is designed to hide complexity. So the cloud provider offer non-abstraction to the customer. So we all say the same things when you look at the top part of the iceberg. But under the same level, the reality is that the way each provider has implemented things can be very different. So if we look, for example, at the hyperscaler, they will look very different from other players because their scale allows them to have custom sealing code manufactured, to use proprietary cooling only designed for their own data center. They operate on a massive scale. And also, because of these custom aspects, they also have a big incentive to not communicate. So generally, the architecture is not well understood outside of the entities. Then you have mid-sized provider like us, which, although we do have sometimes some custom hardware made, but it's much rarer. So generally, most of our equipment will be based on standard off-the-shelf equipment we can purchase. So the servers would be much more standard. Scale is smaller, which also means we have a bit less to hide. So generally, that's helps being a bit more transparent. You have companies that have private clouds and premise. So in that case, the good thing is they know exactly what they have, although they will have the same issues and the others to really understand the impact. And often they might not have necessarily even the like methodological know-how on how to do that. So in terms of the product, in particular, so as a software layer, because basically the cloud is taking all this hardware and then finding ways to split it and to resell it in plenty of different ways using software. Like the way things will be implemented will be very different. So if you consume object storage, you will consume the same API, the same abstraction to with all the different providers, but like the way it's implemented under the scene will be totally different from one provider to the other. Even the VM will be probably different enough that you can't really compare them in the same way. Second reason, nobody will share the data that you need if you want to understand your impact. I mean, in order to do this lifecycle assessments, you need a lot of data, precise data. You need to know the exact server counts, the models, utilization rates, cooling efficiency. And as Simon mentioned it, I mean, this is part of the competitive advantage of the cloud provider to have the right recipe to make money, and so there will be strong incentive to not communicate about that. I mean, you would communicate too much about your operations by giving the data that would be needed to do a good environmental impact assessment. That means that it will always stay a black box. Trust cannot come from data transparency because it will never happen. So the only solution is that it can come from methodological transparency. So basically, if you have like a shared methodology that explain what to count, how to count it, what's the scope, what are the boundaries, then you can start having like environmental reports that mean something. And just as in the financial world, in the accounting world, like no company is publishing their whole general ledger. Like they have accountants that will take the data in the general ledger and then produce a standardized accounting report, which can be shared externally and that anybody can understand because they're all made according to the same accounting rules. So that's basically what we need for sustainability, like to have the provider being able to use such a methodology that it can be audited to be correct, and then customer could have data that they can trust. But the third reason why it's difficult to get like good numbers is that actually all this data that you need is often of low quality. So the first type of data you will need is inventory data. You need to know what you have in your data centers, all your equipment, and everybody thinks they have good data until they try to use the data. Like if you look into your DCIM, even if you have one, generally when you start using at the level you need for an environmental assessment, you realize you have errors, you are missing specs, you are missing, maybe there are errors with serial number, you have the devices that you don't know where they are. It's always much messier than what you thought. Then you also need usage data. So usage data, usually you have some because most cloud providers charge a customer generally through by how much the customer uses. So you have to like collect this usage data in order to build your customer. So that's a good thing. But sometimes, and that was the case for us, the initial usage data we had when we looked into it didn't have the right dimension because the Exoscale was not charging a different price per location. So we were not collecting the location where you used in the usage data because we didn't need for billing. But then when we decided to use usage data for environmental accounting, then that became a problem, so we had to solve this. The electricity factor is also something where it's very complicated to get good data. And again, shout out to electricity map again, because that's one of the, well, it's clearly the best source if you want granular data at the moment. Otherwise, it's very complicated and you end up using like yearly average, which is really not the right way to look at it when you have something as dynamic as the cloud. And finally, embodied impact. So that's like a very tough nut to crack. As we saw, this part could be actually one of the major contributors, depending on how clean your grid is, and there is very little good data. Why? Because there's a very complex supply chain that's very opaque and that don't communicate anything. So you're forced to rely on generic data, on some studies, on some database, like what was this? Yeah, well, like the Buena Vista database, for example, or lower level database. Anyway, it's a complicated topic. So let's talk about the opacity of the supply chain, which is for reason which this is very complicated. So like the main thing we're talking about when we're talking about the cloud is semiconductor. And it's a highly opaque and concentrated supply chain and industry. Like if like everybody's talking about the price of the RAM exploding, where one reason there's only 3 companies that makes basically all the RAM in the world. You have SK hynix, you have Samsung, you have Micron. That's it, 93% of the market. You want a CPU? For server CPU, there's 2 players, AMD and Intel. That's it. And on the fab side, besides Intel, which has its own fabs, while there's basically a company that makes everybody's chip. It's TSMC. And those companies, I mean, they probably could like communicate, but they don't have any incentive to. And the reality is, so currently we have very little information coming out about what the actual environmental impact is that comes with the chip when you buy it. So all this boils down to how the marketing. So what happened is that the hyperscaler moved first, like to communicate environmental information. They were the first to implement some methodology to get some estimates and propose data to the client. So we can at least acknowledge that they were the first to move. The problem is that when they did it, for sure, there was no methodology besides like lifecycle analysis that doesn't tell you how to do it for the cloud. So everybody did their custom thing. They implemented their custom calculator, taking different assumptions, and that's how we arrived with some carbon neutrality claims based on PPAs, which clearly amounted to greenwashing. So they stopped claiming this. So now the situation is that if everybody reports differently, we have numbers that are meaningless. And what we need is that now that everybody is catching up, everybody, thanks to CSRD, is moving hopefully to be able to provide these numbers. And open methodology are emerging. There are open standards that are emerging. We'll talk about some of just later. And that would allow the provider to report on the same things and for the customer to be able to trust the data that they're getting. So that green actually means something. Now we'll give the mic again to Simon to talk how we're solving that issue. The issue of the lack of transparency and the low quality data.
Yes. Okay. So the short answer to this is standardization, which isn't particularly sexy, but it works very well. So the leaders here are the French environmental transition agency called ADEME. And ADEME came up with this thing called Product Category Rules, which is basically an open framework that tells you how to assess the impact of your cloud. Now, that was developed with some actual practitioners, big names that you'd recognize, others that perhaps you don't. And the goal is to make this the European standard that will then be law for all cloud providers who operate in Europe to implement. And so a brief timeline, it's relatively recent, 2022, ADEME started the work. They produced a V1 in 2023. And then in 2024, we were part of a working group where we kind of exposed this to the real world, improved it, made it more modular, more realistic. And now, 2026, it's in use. We use it every day, as do other providers. And it's moving towards the EU level, which takes time, of course. So the other side to this, we start with the PCR, which tells you how to measure things. And a key part of any standardization is certification. And this is where TCO comes in. You may or may not recognize this logo. TCO is an organization that deals with environmental impacts of technology. And so what TCO does is they say, this cloud provider is correctly implementing the PCR, but they also put some requirements on the operational efficiency. So in terms of, do you have good data and are you actually doing anything with it? A big problem with this kind of reporting is you say, you need to report a number. Someone reports a number, and that's it. That could be a randomly generated number. You have to have someone say, is this a good number, and is anything being done with it? And that's where this TCO stuff comes in. PCR, how to do it. TCO, proof you're doing it well. So the other problem here, day to day, is actually that this PCR thing here is an absolutely massive PDF with loads of equations in it. And it takes a long time to implement the calculations. And so what we did was built this thing called Cloud Assess in collaboration with two other companies, Resilio and Kleiss, both Swiss companies. And it turns this big fat PDF into some executable rules. So you can define the rules in this format called LCA as code. It looks a bit like this. And then Cloud Assess will execute that, and it guarantees that it's compliant with the PCR. The reason this is good, not only does it save time in implementing things, but it's versionable, it's testable, it's reproducible, and you can automate it. Then, when the auditor comes knocking on your door, you can say, check this out, here's my rules. They say, oh yeah, we know this works. Cloud Assess itself takes a bunch of input data, which we'll talk about in a second. And then it runs these rules and gives you these multi-criteria output. That means different kinds of impacts on different things per user, per service, per region, etc. The big but of this is we still need to get this data. This is the data we've just spent the last 20 minutes telling you how difficult it is. So as much as we can build rules and build systems that implement those rules, the data itself is still a problem. And this is really the key takeaway, that no matter how many rules and standards and methodologies we put in place, the industry-wide lack of data is just a common problem. Unfortunately, that's not really something we can fix on our own, but we're trying. And so this kind of thing, it took us about 3 years to go from nothing to having some reports. Nowadays, that would probably take 6 months, given that the regulation is in place, there's tools and stuff. Oh yes, back to Guillaume, sorry, spoiler.
Thank you. Okay, so now let's conclude with some actions that you could take, like if you actually care about what we're going to be talking about. So first is to start asking questions. Ask questions to your provider. Ask them, ask them for their estimate, but also ask them how they came up with them, what was their methodology, what was the scope, what standard did they use. And if they can't answer those questions, well, in that case, you have marketing claims, not proper environmental claims. Then you can also put sustainability in your procurement process and maybe favor purchasing from companies that have a good track record of actually doing this stuff correctly and being able to properly communicate on what's the environmental impact of the services that you're purchasing. Third, maybe don't wait. There is a CSRD. If you're in scope, probably you haven't been waiting, but even if you're not, it's worth already caring about that, making sure you have the figures, because the client or maybe the regulator at some point will ask you about this, and it's gonna be much easier if you have the time to tackle on the problem rather than having to scramble and try to find something, to put something in place quickly. And finally, request open shared standard like the ADEME PCR. As Simon hinted about, we know it's being made into an international standard, so free is soon not going to be that French thing. So I will say there's an English version, so you can still go on the ADEME website to download it and have a look. But yeah, it's really important that there is demand for data implementing globally accepted open and shared standard, so that more and more actors are incited to what to use. So some closing thoughts, that would be the main thing. Like if we want to be able to compare the claims that different players are making, we really need that shared methodology. And the tool exists. So you've seen Cloud Assess, which is open source. Anybody can use it. We have the methodology like the ADEME PCR. What's missing is really just the will to implement them and to use those tools. We know it's not perfect. The data is still a big problem, but it's better to be imperfect but rigorous rather than having something that looks red but actually is made up. So yeah, cloud sustainability should be less about claim and more about accounting, like explain like the financial accounting analogy. So thank you, and thank you also to the organizer. Here you have some information. So in particular, you have the address for the Cloud Assess tool if you're more interested in that, with the address of the source code as well. If you want to get in reach with us, you can find me on LinkedIn. Enjoy the rest of the summit.